Good afternoon, guys. So this is my final code. You can see that I have the two libraries downloaded here, which is the Arduino BLE, which is Arduino Bluetooth Low Energy for wireless low energy communication. I've got the Arduino LSM6D S3, which is the Arduino IMU built into the Arduino Nano microcontroller. So by using these libraries, I can communicate, these two codes can communicate wirelessly, and this can initialize the IMU. As you can see, from line 12 to line 20 is the void setup, where the initialization of the IMU will begin. Line 22 to 25 will show the other library, which is the BLE. It shows the initialization. As you can see, that this is the BLE gesture service. You can see that this is the void loop, where we have to access X, Y, and Z. You have the IMU. We lines 47 to 56 are the commands. So we have the tilt thresholds and the roll. Tilt and roll. The threshold and roll. You can see the pitch and roll is the orientation and tilt. We've got the commands F, B, L, R, and S. F is forwards, B is backwards, R is right and left, L is left, and S is stationary. So we have the serial pitch roll and command. I've already stated this, and that's the IMU gesture, which is the code for this microcontroller, which I'll show now. So this is the Arduino Nano 33 IoT. You can see it's got the IMU and the BLE built into it. So this represents this. So this is the gesture control. As you can see, it's not doing anything now because I've not got it connected. So now I will show you this code, which is my prototype, which I'll show you right about now. So as you can see, this is my final prototype. We've got the Arduino Nano 33, which communicates wirelessly to that one. We've got the left ultrasonic sensor, the HCSOR4. We've got the right ultrasonic sensor, and we've got the front one right here, which is under here. As you can see, it's there. So these orange, I've color coded everything to make it easier for us. So the orange one is the ground, which you see ground is there. The yellow is VCC, we've got the VCC there. And the trig and echo pins are connected to the Arduino board, which is the red and green pins. Yeah, so as you can see, the DC motors are around down here. Both of them are there. You can see both of them there. To make this work, I've connected the motor drivers here. The motor drivers will be connected to the Arduino board, and then once the IMU gets processed through the Arduino, then we can then connect the motor driver to the DC motors. So you see I got USB. This is the power supply I'm using for the motor driver, which is 12 volts. You can see to power both the ultrasonic sensors and the motor drivers at the same time, the DC motor will be used to have 12 volts for this, and the Raspberry Pi 3, which is a 5 volts power supply in this case, will be used to power the 3 ultrasonic sensors. So now I can show you the code that will represent this. So this is the receiver code, which is this prototype I showed you. As you can see, this for wireless communication, it just needs the Arduino BLE, as it doesn't need the IMU, because that code uses the IMU. You can see that the setup of the motor pins, this ENA, IN1, IN2, ENB, IN3, and IN4 is the pins on the motor driver, and 987654 is the pins on the Arduino, which I've connected. You can see the ultrasonic setup, trig underscore F, which means trig front sensor, echo front sensor, trig left sensor, echo left sensor, trig right sensor, and echo right sensor. You can see we have connected it to pins 10, 11, 12, 13, A0, and A1 of the Arduino Nano 33. So this is the most important line in my opinion, lines 18 to 19, which is a safe distance equals 20 centimeters. I've implemented an emergency stop at 5 centimeters. So if it's less than 5 centimeters, it will immediately stop if the obstacle is this close. It will override everything. So even if I'm performing a gesture like forwards, if this ultrasonic sensor is less than 5, if I put my hand here, for example, which is less than 5, it will automatically stop. It overrides everything, which is a key feature. As you can see, we've got the BLE service. We've got the motor sense, the motor cell, the pin layout. You can see the outputs and inputs. We've got the BLE initialization. We're scanning for the gesture service. We've got the peripheral. We've got the emergency stop, the trig, the distance. We've got the BLE. You can see this is a very long code. You can see everything here. So now I will show you the serial monitors of both codes in a second, just about now. The Arduino Nano 33 gesture control. As you know, it already has the IMU, which means I don't need to have the gyroscope and the accelerometer by itself. It's integrated into here. So this gesture means front, I want you to guys remember this, as the wire is very short that was given to me, so there's not much I really can do. So the gestures, you won't be able to see it, but I'm telling you now what it is so you guys know. So once I've performed this gesture, this is right, this is left, I think I've already said this, but this is forwards, and this is backwards. And this, when it's not moving, is stationary. Now, I'll perform these without showing you this, but I will show you the command on the serial monitor now. You can see, this is stationary. I'm currently doing it, you can see my hand there. Still stationary. This is, there, this is left. You can see I'm doing it there. I'm gonna perform the right, which is there. Perform forwards, which is right about that gesture, and backwards, which is this one. So once I perform these gestures, once I plug in the port for this one, this will start doing the commands, and I will start showing you this once I've connected it. See, this is the gesture. I got a PR to help me out with the ultrasonic detection. So when I tell you to put your hand over it, could you please put your hand over it? So I'm performing the right. You can see it's moving. Could you please? As you can see, that's the emergency stop. Can you keep your hand there, please? Keep your hand in front of it. There you go. You can see emergency stop. And then you'll perform the right function, bro. Now put your hand in front of the other one, the left one, bro. As you can see, now move your hand away. See, as you can see, the obstacle selected. So this emergency stop overrides everything. And there you go, that's my prototype. Thank you very much. As you can see, the Raspberry Pi is powered for the ultrasonics and the motors work.